Good morning, good afternoon, wherever you may be in your day. As always, thank you for choosing to make chemistry part of your day. We're going to introduce the idea of mass percents in a general sense on this video, and this will link to another one where we talk about how to use those mass percents to actually determine something about the chemical itself. So if we're doing more of an analysis approach from a more practical data sense. All right, let's get to it. Okay. So, definitions. Before I talk about mass percent, I want to talk about any percentage. Hopefully you are all very comfortable with percentages. Lord knows we are thrown enough percentages in our day-to-day life. Hopefully by this point you've realized that any kind of percentage that you see is just a ratio of the part over the whole times 100. It's an easy way of going from decimal to whole numbers so that our brain conceptualizes it better. Typically in math and physics, chemistry, biology, etc., geology, we're actually going to use the ratio, not the percent part, not the 100 part. So, for example, and this is going to date this video, and I probably shouldn't do it, but right now Donald Trump has 20% of the we'll just say GOP primary voters backing him. So what does that mean? Well, that means 20 out of every 100. So again, you got to think of the part. So 20 is going to be 20% of the voters out of all of the voters. So again, anytime you see these percentages, you see them all the time. It's always part over a whole times 100. And they're going to literally say it in the sentence. Blank percent of blah. That blah is the part. And then you have to use common sense to think what would represent the total. And if it's well done, it should be between 0 and 100. Usually you don't exceed 100% unless you're talking about change over time. Okay, so let's bring this back to chemistry. Mass percent of A, or mass percent of, say, nitrogen, oxygen, carbon, hydrogen, typical things you see, sulfur. That would be then the mass of A, or the mass of sulfur, oxygen, nitrogen, whatever you asked of, over the total mass. Typically, that's either going to be a sample, they're going to say a 10-gram sample, or it's going to be out of the compound itself, in which case you'd have to get the formula weight. Then multiply by 100. So, easy speasy. Let's do an example, be done with this topic, and move into the more analytical approach. All right. Determine the mass percent of nitrogen in ammonium nitrate. Once again, hopefully you're getting used to this. Using the words, expecting you to know the symbols. Ammonium is not an element on the periodic table. Am is not ammonium. It's a polyatomic ion we have correctly memorized not only as NH4, but it's NH4 with a positive 1 charge. Nitrate we have also memorized as NO3-, equal charges, so NH4, NO3 is our formula for ammonium nitrate. We need this to know how much nitrogen. So if we want the mass percent of nitrogen, percent nitrogen, it's going to be the grams of nitrogen over our total grams times 100. So what would this look like? All right. So our grams of nitrogen, if you look, nitrogen shows up in two places. You could argue this is a trick question. From our friend, the periodic table, we find nitrogen is 14.01 grams per mole. So we have two nitrogens, and then on the bottom we just put our formula weight. So it's going to be 2 nitrogens plus 4 hydrogens, plus 3 oxygens, and again our normal formula weight times 100. And reasonably speaking, it's 2 out of, 9 molecules, so we expect this to be, 30-40%, something like that. All right. Sorry about not doing this beforehand. So on the bottom I get 80.06. And I get a percentage of 35.0% nitrogen. And that's really all there is to it. If we want to do this for oxygen, the bottom would stay exactly the same. So if we did this for oxygen, we would just take 3 times 16 over 80.06 times 100, and we would get 60.0%. And now, if we want to do hydrogen, I just want to do this to point it out, we can do this two separate ways. We could add this up and subtract from our total percentage, which is 100, which would leave me with 5% hydrogen. Or we could do the same calculation, 4.04 divided by 80.06 times 100, and we'd also get 5%. And there you have it, percentage of an element from a formula.